possible imminent eruption of Mount Spurr in Alaska can be scary. Mount Spurr, named after Josiah Edward Spurr, a geologist and explorer with the United States Geological Survey, who led an expedition to the area in 1898, is one of Alaska's most fascinating natural wonders. This is a land at the edge of the world, where nature reveals itself with a power and grandeur rarely found elsewhere. Located about 80 miles or 130 kilometers west of Anchorage, Alaska's largest city, Mount Spurr rises majestically to an elevation of 11,070 feet, or 3,374 meters above sea level. It is the tallest volcano in the Aleutian volcanic chain, a region that stretches for about 1,550 miles or 2,500 kilometers along the northern edge of the Pacific Ocean and is home to over 40 active volcanoes. This volcanic chain is part of the so-called Ring of Fire, a geologically active belt that encircles the Pacific Ocean and is responsible for some of the most powerful volcanic eruptions and earthquakes in the history of our planet. Mount Spurr stands as a prime example of this activity, a towering giant where tectonic forces, geological dynamics, and surface processes continuously shape the landscape. But why are we talking about it now? Well, as you'll see in this spectacular video brought to you by the Insane Curiosity channel, there's a very specific reason. Experts are warning that the beast might be waking up and could erupt any time soon. So what do you say? Let's dive in and find out more about what's going on. From a geological perspective, Mount Spurr is classified as a stratovolcano, also known as a composite volcano. This is one of the most common and awe-inspiring types of volcanoes. Stratovolcanoes are built up over time through successive eruptions that alternate between viscous lava flows and deposits of pyroclastic material such as ash, lapilli, and volcanic bombs. This process of layered growth gives the volcano its characteristic conical shape, with steep slopes and walls often carved by deep valleys formed through erosion. Mount Spurr's position, rooted in the continental base of the Aleutian island chain, is deeply tied to the dynamics of plate tectonics. It owes its existence to the subduction of the Pacific Plate beneath the North American Plate, a geological process that has not only formed volcanoes, but also created a series of stunning islands and breathtaking landscapes. Being located at the base of this volcanic arc places Mount Spurr at the heart of a dynamic and ever-evolving geological context, where the forces of nature are constantly at work. As the oceanic plate continues to be pushed beneath the continental plate, the increasing heat and pressure cause partial melting of the rocks, generating the magma that fuels the volcanoes along the chain. This process is far from uniform, with variations in intensity and distribution creating volcanoes with unique characteristics. Mount Spurr is one of the youngest and most active volcanoes in the chain, a testament to just how dynamic this region still is. Mount Spurr is located within a vast summit caldera, an enormous circular depression approximately 3 miles or 5 kilometers in diameter. Calderas form during particularly violent eruptions when a massive amount of magma is expelled, causing the ground above to collapse. Inside Mount Spurr's caldera lies a secondary cone known as Crater Spurr, which has been the primary vent during historical eruptions. This crater is an area of significant scientific interest, as it represents the point where deep geological forces manifest at the surface. It is here that volcanologists focus much of their research, using advanced instruments to monitor volcanic gases, seismic activity, and other indicators that might signal an imminent eruption. Unlike other volcanoes in the chain, Spurr has exhibited a particularly complex dynamic over the millennia. Its behavior is alternated between effusive eruptions, which gradually reshape its slopes, and explosive ones capable of hurling ash clouds miles into the atmosphere, transforming the surrounding landscape into a mosaic of destruction and new formations. Thanks to modern technologies like INSAR, interferometric synthetic aperture radar, a remote sensing technique that uses radar satellites to measure ground changes with pinpoint accuracy, detecting soil movements, deformations, and topographic variations. Researchers have observed that Mount Spurr's structure is far from static. Every minor vibration, every subtle deformation of the ground is a signal of an apparently dormant system quietly building energy, waiting to reach a critical point. In this context, Mount Spurr stands out as a symbol of instability. While it hasn't produced a catastrophic eruption in recent decades, the subtle signals, such as the ground rising by just a few inches or a few centimeters per year, or nearly imperceptible microtremors, suggest that its magma trapped in a low-pressure rock chamber could erupt at any moment. Such an event wouldn't just alter the local landscape, but could trigger cascading effects throughout the entire Aleutian volcanic system. Mount Spurr's geographic location, in an area where the Earth's crust is relatively young and warm, adds another layer of intrigue. Unlike older, more sedimented volcanoes, the lack of a thicker layer of sedimentary cushioning here means that the energy builds up without a natural buffer, making potential eruptions more violent. This characteristic, combined with its basaltic and andesitic composition, gives the volcano a dual nature. Basalts, for instance, are classic rocks of mid-ocean ridges, oceanic crust, volcanic islands formed over hotspots, and continental plateaus, while andesites are the quintessential volcanic rocks defining subduction zone arcs, whether they are island-based or continental. This unique mix results in periods of slow, almost imperceptible magma release, alternating with moments when the volcano wakes up suddenly, unleashing concentrated energy that could erupt in an instant, transforming entire surrounding areas in the blink of an eye. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. Yet despite its catastrophic potential, Mount Spurr has maintained an appearance of calm for much of its history. Historical observations, though sparse for the period before the modern era, suggest that the area around the volcano was often described in poetic terms, as a place where the Earth breathes slowly, releasing its energy in a steady flow. This flow, though imperceptible to human senses, has left an indelible mark on the rocks and landscapes of the region. Ancient records, explorers' accounts, and the earliest observations by the pioneers of Alaskan astronomy speak of skies darkened by ash clouds and long periods of tranquility punctuated by brief but intense episodes of seismic activity. During the era of northern exploration, the few inhabitants and explorers of the region told stories of the day the mountain shook and how the waters of the surrounding oceans were momentarily transformed into rivers of lava and ash. Smoky legends perhaps, but with the advent of modern monitoring technologies, we've been able to map these events with a precision that makes the breadth of Mount Spurr over the centuries almost tangible. The first documented eruption, however, took place in 1953, when a series of violent explosions sent ash plumes soaring up to 3 miles or 5 kilometers into the atmosphere. It was a relatively short-lived event, but it left a lasting mark on the collective memory of local communities. After nearly 4 decades of dormancy, Mount Spurr erupted again in 1992, in what is considered one of the most significant volcanic events in Alaska's recent history. Interestingly, this eruption did not occur at the volcano's summit, but instead originated from Crater Peak, located about 2 miles or 3.5 kilometers from the top. The eruption unfolded in 3 distinct phases, in June, August, and September. The most violent phase occurred on August 18th, preceded by increased seismic activity, a clear indicator that magma was rising toward the surface. When the eruption finally happened, the volcano once again spewed enormous amounts of ash, which blanketed a wide area and caused significant disruptions. The city of Anchorage, despite its remoteness from the volcano, was hit by a rain of ash that brought daily activities to a halt, forced the airport to close, and raised public health concerns. Shortly after the eruption, two scientists and the wife of another took a small plane to get a closer look at the eruption plume. It is this very footage that we're showing you today. The eruption itself lasted only a few hours, but the ash plume reached an astounding height of 49,000 feet or 14,000 meters and hurled volcanic bombs up to 6 miles, 10 kilometers away. This event underscored the critical importance of effective and timely volcanic monitoring, prompting local and federal authorities to improve alert and preparedness systems. In fact, it was during this time that the Alaska Volcano Observatory, the AVO, was established. The AVO plays a crucial role in monitoring Mount Spurr and other active volcanoes in the region. Using a network of seismic stations, high-resolution cameras, and gas detection sensors, AVO scientists continuously track signs of volcanic activity. One particularly fascinating aspect of this monitoring is the analysis of volcanic gases, such as sulfur dioxide, SO2, and carbon dioxide, CO2. These gases provide valuable insights into the depth and composition of the magma chamber, helping volcanologists predict potential eruptions with greater accuracy. Mount Spurr isn't just a geological wonder, it's also a vital part of the local ecosystem. Its slopes are home to a variety of plants and animals uniquely adapted to the harsh conditions of the region. Volcanic ash deposits, rich in minerals, create fertile soils that support an immense biodiversity. However, climate change is having a significant impact on Mount Spurr's landscape, particularly on the glaciers that cover its slopes. These glaciers are retreating at an alarming rate, disrupting the local hydrological cycle and increasing the risk of glacial outburst flows, known as Jökulhlaups. Culturally, Mount Spurr and the Aleutian chain hold deep meaning for Alaska's indigenous peoples, such as the Aleut, who have lived in the region for thousands of years. For these communities, volcanoes are not just natural phenomena, but also spiritual entities, central to myths and legends that reflect a profound respect for the forces of nature. Even today, Mount Spurr continues to inspire awe and fear, standing as a symbol of the planet's untamed power. And as it turns out, the few residents of this cold, isolated region have good reason to be wary of the sleeping giant. Since last summer, the area around the volcano has been shaking with tremors and rumbling ominously. In fact, just recently, the Alaska Volcano Observatory, the AVO, raised its color concern code from green to yellow. Seismographs are currently recording about 30 earthquakes per week, with a sharp increase since the beginning of the year, up to 125 seismic events per week. The strongest so far occurred on Thursday, January 2, 2025, with a magnitude of 2.9. While not particularly strong in absolute terms, it's still a signal that experts aren't taking lightly. Given the significant increase in seismic activity, experts believe an eruption could occur in the coming days or weeks. However, it's also possible that the earthquakes could subside and the threat might diminish over the next few months. As of now, scientists estimate a 50% chance that the volcano will erupt. Let's reiterate, Mount Spurr is not the type of volcano that erupts with flowing lava like those in Hawaii. Historically, it has produced massive ash plumes that can reach heights of up to 45,000 feet or 13,700 meters into the atmosphere. As a result, the primary danger seems to be the disruption of air travel between the United States and Asia along major flight routes that connect places like New York and Tokyo, following the curvature of the Earth and passing directly over Mount Spurr. This time, however, experts cannot rule out the possibility that the eruption might originate not from Crater Peak, but from the summit itself. If that happens, the eruption could be far more violent. A summit eruption would likely be explosive and might even generate lava flows. It could also melt significant amounts of glacial ice, potentially flooding the surrounding area with pyroclastic flows, mudslides, and ballistic debris. Fortunately, the area around Mount Spurr is almost entirely uninhabited. At this point, seismic activity alone cannot determine exactly what will happen at the volcano in the coming days. However, the current unrest suggests that an eruption could indeed be imminent. The latest bulletin from the Alaska Volcano Observatory, issued on March 26th, reads, "Unrest continues at Mount Spurr volcano. Seismicity remains elevated with numerous small, shallow volcanic earthquakes detected beneath the volcano over the past day. Satellite data detected weak sulfur dioxide (SO2) emissions from the volcano, consistent with recent measurements made from aircraft. Clouds obscured satellite and web camera views of the summit. No activity was observed in clear web camera views of Crater Peak. AVO continues monitoring activity at Mount Spurr for signals indicating that the volcano is moving closer to an eruption. Based on previous eruptions, changes from current activity in the earthquakes, ground deformation, summit lake conditions, and fumarolic activity would be expected if magma began to move closer to the surface. Therefore, if an eruption occurred, it would be preceded by additional signals allowing warning. So for now, all we can do is wait and hope that this story ends with nothing more than a harmless, awe-inspiring fireworks display."